You are managing infrastructure using Deployment Manager and have provisioned a GKE cluster. You want to deploy a DaemonSet resource into the kube-system namespace within the same deployment template. Which method provides the most direct integration using minimal additional services? Option A, register the cluster's API as a type provider within Deployment Manager to allow native creation of the DaemonSet. Option B, employ the Deployment Manager Runtime Configurator service to define a new configuration resource for the DaemonSet.
Option C, provision a separate compute engine VM that executes a startup script to apply the DaemonSet manifest via kube control. Option D, include the DaemonSet manifest as a specific key value entry within the GKE cluster's metadata field inside the Deployment Manager configuration. When thinking about this, consider how Deployment Manager handles various resource types and what mechanisms allow it to interface directly with external service APIs, such as the Kubernetes API, without introducing extra layers of abstraction.
In my view, the correct answer is option A. Deployment Manager is designed to manage infrastructure through defined resource types. By registering the Kubernetes API of your GKE cluster as a type provider, you effectively expose the Kubernetes resource model to Deployment Manager. This allows you to declare Kubernetes objects, like DaemonSets, directly in your template as if they were native Google Cloud resources. This is the most efficient and direct integration method, preserving your infrastructure as code workflow.
All right, so one possible answer to this question is option A, using a GKE security brief for deploying documentation resources. Now, option A is the correct answer because it leverages a built-in Google feature specifically designed for deploying configuration objects onto your Kubernetes cluster objects. Infrastructure deployment with a security brief is a great way to control and manage the lifecycle of these resources. Other options are less optimal. Using a compute engine VM with a startup script, as suggested in option C, introduces unnecessary overhead and maintenance for an external service. Option D suggests using metadata fields, which is not designed for resource deployment and would not function as intended. Finally, option B involves the runtime configurator, which serves a different purpose and is not the standard approach for managing the lifecycle of Kubernetes cluster objects.